This is CIE Paper 2 Further Pure Mathematics 2. And this is the most recent paper, October-November 2025, variant 24. The first question here is asking about reduction formula. Reduction formula is reducing the power of n into lower powers. Because the integrand is a product of a polynomial xn and sinh, so integration by parts is the most efficient method, especially when we are asked to form this reduction formula. Here I chose u to be xn because differentiating reduces the power, which is essential if we want to relate in to in minus 1, in minus 2, etc. I chose dv to be sinh x dx. To get v, I need to integrate on both sides. So v is cosh x. Let's now apply this rule, integration by parts rule. In is going to be the product of uv minus integral of v du. And here u is xn, v is cosh, and then I have integral of v and then du, nxn minus 1 dx. So this is u, this is v, and this is du. And this is over 0 to 1. Then let's do some calculations. Substituting 1, I got 1 cosh 1 minus 0 minus n into x n minus 1 cosh dx from 0 to 1. Here, again, the integrand is a product of xn minus 1 and cosh x. So I'm going to integrate by parts again. And then I'm going to choose u to be my xn minus 1. Differentiating u again, it's going to reduce the power to n minus 2. So I'm expecting to get in minus 2 in my answer. Then this is dv. To get v, I need to integrate cosh x, which gives me sinh x. So in equals cosh 1 minus n into uv minus integral of v du again. So in is equal to cosh 1 minus n, and I'm going to apply the rule. U times v minus integral of v du. This is u, this is v, and all of this is du. So here I will get in is equal to cosh 1 minus n xn minus 1. I'm going to distribute n over what's inside the bracket. This between 0 and 1 plus n minus 1, and then xn minus 2 and sinh x dx. Did you notice that this part is similar to in, but with a power of n minus 2? So in is cosh 1 minus n sinh 1 plus n into n minus 1 in minus 2. Proved. Now let's distribute the marks. We have accuracy mark here for substituting the limits. We have a method mark here to apply integration by parts again. And the first method mark is to apply integration by part, and xn cosh x must be seen. In part B here, they asked us about finding I2. This part is straightforward because we've already done the hard work in part A. We just apply the reduction formula. So In equal cosh 1 minus n sinh 1. This is what we got from part A. Now we need to substitute n equals 2. So I2 equals cosh minus 2 sinh 1 plus... since we already have a reduction formula, we should not integrate from scratch again. The examiner expects us to use the results from part A. The reduction formula brings us to I0, which is intentional because I0 is very easy to evaluate directly. So I0 equals integral of x0 sinh x between 0 and 1. So this is sinh x dx, and the answer is cosh x between 0 and 1. So I0 is cosh 1. Because the question asks for an exact value, we keep everything in terms of sinh 1 and cosh 1, and we do not use decimals. So substituting back I0, be careful and simplify at the end. Marks are often lost through algebra, not calculus. So I2 equals 3 cosh 1 minus 2 sinh 1 minus 2. Let's distribute the marks now. We have accuracy mark for the answer, and Cambridge also accepts the answer written in exponential form. So if your answer is half into e plus 5 over e minus 2, that's totally accepted. There's a method mark to apply the reduction formula.